Welcome back, Maths Easy, step by step. In this part 109 video, I have a different question. It's different, it's much different than before. So don't just see this and think it's the same as different. I'm telling you, it's different. We're using the same color coins, but it's a different question. Hey, let's just jump right on in here and get to it like my old grandpappy used to say. Glass jar has 5 blue coins, 4 red coins, 3 green coins, 2 purple coins. What fractions of coins is blue and red? Blue and red. And typically means addition. So we're combining both blue and red color coins. What would the fraction be that would represent that? Would it be A, 7/14ths, B, 9/14ths, C, 3/7ths, or D, 1/2? Take a look at these options, A, B, C, and D. Is there anything that looks out of place with any of those fractions? Okay, so this is a test-taking strategy. Anytime you have options A, B, C, and D, you want to try to follow these test-taking strategies if possible. Do you see anything out of place? All right, so option A, you can eliminate. Why? Because 7/14 is not reduced, right? I can divide 7 into top and bottom. 7 divided by 7 is 1. 14 divided by 7 is 2. 1/2 is the reduced or simplified version of 7/14. Eliminate A. All right, so let's visualize fractions. Now we're going to create fractions based upon the word problem. And remember, parts go on top, the whole or the total goes on the bottom of your fraction. Okay, so in this particular test question, they're asking you to create a fraction, or what fraction represents both blue coins, which is here, it's 5, and red coins, which is 4, right? Remember, those are the parts to the whole. When you add up all the coins they mentioned in the word problem, there are a total of 14, right? So that's your denominator, 14. So there's something special. You just can't add 5 plus 4, right? Because there's something special that you need to have when you're adding fractions, and that's a common denominator. Okay, so for this particular problem, our fraction is going to be represented right here, right? Blue coins and or plus red coins over the whole or the total. And so since our total was 14, that means 5 over 14 plus 4 over 14, which I'm showing you here. Now, are the denominators the same? Yes. But until the denominators are the same, and you know that, right, you have to weigh it off on adding the numerator, the top part of the fractions. But since we know 14 total coins, 5 blue out of 14 total coins, plus 4 red out of a total of 14 coins, then we can add the numerator 5 plus 4. What's 5 plus 4? It's 9, and the denominator stays the same, 9/14. Now, you know I'm going to ask this question. You know I'm going to ask it. You know it's coming. Can you reduce the fraction? You knew it was coming, right? We've got 9 in the numerator. We got 14 in the denominator. We have an odd number on top, an even number on bottom. Is there a number other than 1 that can be divided evenly into both top and bottom? Okay, so we have 9/14. All the multiples, or the products that make up 9, are 1, 3, and 9, right? Because 3 times 3 is 9, and 9 times 1 is 9. So can I divide 1 into 14? Yeah, but we can't do that to reduce fractions. Okay, what about 3? Can I divide 3 evenly into 14? Is there a number times 3 that gives me 14? No. Is there a number times 9 that gives me 14? No. So if there's no numbers other than 1 that can be divided into top and bottom, it cannot be reduced. So only 1 can be divided evenly in top and bottom, and you end up with the same exact fraction. You can't reduce it. You cannot shrink that fraction. So no, it cannot be reduced. So the answer is B. There are 9 blue and red coins out of a total of 14 possible coins. Math is easy. Take it step by step. Thank you for joining me. I appreciate your time. Hey, if I've helped you, please help me to help others. Like, follow, share, and subscribe.